ultra wide band communication. So I told you about frequency hopping, then the other one which we're using the CDMA, then we have the ultra wide band. This is the underlying. You see, all these are working here. There is underlying figure. So ultra wide band, the name suggests this kind of communication. It sends a series of low energy rapid pulses, and at the same time changing or varying their carrier frequency. This carrier frequencies is changed to communicate information. Okay, so the UWB, you can define it as a signal that have a bandwidth of at least 500 megahertz. 500 megahertz. Or if you take the frequency band, this center frequency you take, it should be at least 20% of the central frequency. So with this bandwidth, this UWB or ultra wide band, this has a great potential to communicate hundreds and hundreds megabits of data per second. This is how it works. It can tolerate strong interference from other narrowband signals, and UWB, it doesn't interfere with the carrier signals in the same frequency band. This is the whole concept here. And this can also be used in imaging through the solid objects. Why? Because it passes through it ground, walls and bodies, and also it can be used as a part of a precise location system. That is why, because it is going through solid objects, and that is why it is used as for imaging, precision radar imaging and precise location systems, so location tracking technologies. So ultra wide band, secure, accurate, reliable, real time, low energy. These are the properties of this UWB. Coexistence also.